One of our geometry essential skills is that of angle-pair relationships. That's just looking at the relationship between intersecting lines and also what happens when we have parallel lines and a transversal cutting through those. So we're going to start by looking at the angles that are directly adjacent or straight across from each other when we have intersecting lines. So one of the things that is the basis of all this is the fact that in any circle there's 360 degrees. Okay? If you can remember that, then it's pretty easy to remember that in half a circle, we have 180 degrees. Now, anytime we have that straight line and we have a line cutting through it, it creates what we call a straight angle pair or a linear pair, okay? Meaning that we have the two angles that are on a straight line right here, and those two angles always add up to 180 degrees. So for example, if you knew that this one was 50 degrees, we know that since the entire thing from here to here is 180, we could do 180 minus 50 to find this angle right here, which is 130 degrees. Okay. Now, we could use that same strategy, okay, to find this relationship as well. So again, we have a straight line, okay? This angle right here is 130. So if we do 180 minus 130, we would get 50 degrees. What you may have noticed here is that these two angles, okay, are both 50 degrees. And these angles are called vertical angles. And vertical angles are formed anytime two lines intersect. They're the angles that are straight across from each other, and they always end up being congruent. Now, to complete our way around the circle, what you're going to notice then is if we were to do another 180 degrees half circle or a straight angle pair, if we were to do 180 minus 50, we would get that this is 130 degrees right here. Again, reinforcing that idea that these vertical angles, again, the angles that are straight across from each other, are always congruent when two lines intersect. So thus far we've talked about the relationships that happen when we have the two lines intersecting. We have vertical angles, such as 2 and 3, which are both 50 degrees. And then we have the other vertical angles, 1 and 4, which are 130 degrees. We also have talked about how on a straight line, we always have 180 degrees. So angles 1 and 2 would be a straight angle pair or linear pair. Angles 1 and 3 would also be a straight angle pair or linear pair, as would 3 and 4 and 2 and 4. And again, that goes back to the everything being based on the fact that there's 360 degrees in a circle or 180 degrees in a half circle. Now, there are also relationships that occur when we have parallel lines and what we call a transversal cutting through it. So these two lines that I've just marked are parallel lines. Parallel lines are lines that move in the exact same direction, and because of that, they will never cross. We also have what's called a transversal, which is the line that cuts through at least two other lines. And that transversal is what helps us to create relationships with some special qualities about them. Now, if you can remember one relationship, the one I recommend remembering is that of corresponding angles. And corresponding angles are the angle that's in the exact same spot on a different line. So for example, if you see angle 2 here, if I were to take that and slide it down to this line, it would fit perfectly on top of angle 6. Okay. And what that means is that these two angles are congruent and they are both 50 degrees. Okay. So corresponding angles are always congruent when lines are parallel. And if you can find one angle, then you can find the rest. Okay, so if 6 is 50, we could use the fact that there's 180 degrees in a circle to find 5, which gives us 130. And from there we have so many options. We could use vertical angles to find out that 8 is 130 degrees. And we could use vertical angles again to show that 7 is 50 degrees. Another relationship that I think is worth pointing out is that between angle 4 and angle 6. Now remember, we just talked about 2 and 6, and we said that those are corresponding angles. And when lines are parallel, we know that they're congruent. So if 2 were 50 degrees, then 6 would also be 50 degrees. Now, if we go back to the linear pair or straight angle pair, we know that 2 and 4 have to add up to 180 degrees because that's half a circle, which is always 180. So we could then prove that 4 is 130 degrees. Now, what I wanted to point out to you right here is the relationship between angle 4 and angle 6. They're very obviously different. One is obtuse and one is acute. But if I were to add those two together, I get 180 degrees. Okay. And the reason that's important is because it provides us a relationship so that if we know one of them, we can find the other by knowing that together they add up to 180. And again, this can all be worked back to those corresponding angles, and then from there we can always use that straight angle pair is 180 degrees to find any other missing angles. So let's look at a little more complex example. So let's say I'm given a problem like this, okay, where I'm told that I have a pair of parallel lines and a transversal cutting through it. I'm told that angle EHB is 2x plus 3 degrees, and HKD is 4x minus 37 degrees, and they're asking me to find the measure of the angle. Well, I'd have to utilize some of that prior knowledge, such as the fact that when lines are parallel, corresponding angles are congruent or equal. So what that means is whatever the measures of each of those are, they have to be exactly the same. And if two things are the same, that means that they are equal to each other. So I could set up an equation by saying 2x plus 3 is equal to 4x minus 37. To solve, I could subtract 2x from both sides, get rid of my x's on this side, and I could add 37 to both sides. And I would end up with 2x is equal to 40. From there, I could divide both sides by 2 and get x is equal to 20. Now, notice this doesn't tell me the measure of my angle, it just tells me what x is. So if I wanted to find the measure of the angle, I'd have to plug it back in. Ooh, that didn't go with it. So for example, on the top one, if I put 20 in for x, 2 times 20 is 40, and 40 plus 3 would be 43. So the measure of this angle would be 43 degrees. And if I were to put 20 into the second expression, 4 times 20 is 80, and 80 minus 37 is also 43 degrees. Now from that point, if they asked me to find any other angle measures, I could use vertical angles, so I know those are always the same, and I could use that straight angle pair, so subtracting from 180 to find that these are 137 degrees.